You have all seen this before because this was one of the tools that was used to teach you multiplication. How long is the left side of this thing? This is not a trick question. 2. Excellent. How long is the bottom of this thing? 4. How big is this thing? 8. Why? Because you have 2 4 times. Yes? And this was one of the tools Mrs. Bad Crumble used to teach you multiplication. Yes? Except she may have had, you have 2 apples on your little math textbook and another apple on your little math textbook. And if there were 4 of those groups of 2 apples, how many apples would you have? And you would all go, "Hey, Mrs. Bad Crumble," and she would give you a stick-on tattoo. And you would all be like, "Yes!" Right? I can tell because a bunch of you are going, because you know that was you going, "Yes!" when you got your stick-on tattoo. Right? Yeah, it was.
No, I had these other ones. My grandpa bought some really inappropriate ones from India. So I went to school with naked girls in my arm. Yeah, and they were on my arms. I had skulls on my chest, and I told everyone they were real. I was like, yeah, I went to tattoo parlor.
Okay. So you're all cool with that, yeah? And then Mrs. Bad Crumble brought this back in about grade 5 when she started talking about area, yes? Because that's how you find the area of something, agreed? And then Mrs. Bad Crumble gave you a formula for area, yes? And that formula for area was length. Why did she put the L by the 4? Even though it's going across, when we all think of this as width, not L for length. Why, Hayden? Because they told you that the length is always the longest side, yes? Everyone agrees? You've all heard that before, right? So that makes that L, that makes that W, yeah? And you spent days on length times width, didn't you? You started out with whole numbers, and then you moved to 2.7 and 4.3. And you were all like, "Oh, you're not fooling me." And you got out Mr. Calculator, and you went 2.7 times 4.3, right? And then you got an answer, and then some of you forgot to say that the answer, whatever it was, it's 13 point blah. Some of you forgot to write units squared. And Mrs. Bad Crumble didn't give you your gold star, did she? Because she said that was wrong if you didn't write it, correct? Okay, good. So we all understand area, right? Right? Okay. What happened when Mrs. Bad Crumble did this? No, it's a joke. It's from a stand-up comedian I like. He calls all his youth teachers Mrs. Bad Crumble. He's a funny comedian, but again, I can't show it to you because he swears a lot. His name is Eddie Izzard. Pardon me? No. What happens when this happens? Now what's the width? The width is still down here. It's still 2, and that's still width, right? Why? Because it's still the shorter side, right? This is 4, and this is length, right? Everyone agrees? Okay, now I'm going to tell you to pretend that this is a building. Now what would you call this measurement? Height, wouldn't you? Because it goes up and down, yeah? On a paper, when I draw it, you all want to call it L. As soon as I tell you it's a drawing of a building, you all want to call it H, yes? Okay. So, but isn't the area of this face of the building still 8? And isn't the area over here still 8? So does it matter where we turn it? Does it matter what we call it? No. But if I tell you I want you to paint one wall of a building, You need to know the area of that wall, yes? But it's going straight up and down, so it can't be length times width, can it? Or is it? Does it matter? No. So, I need you right now to get length, width, and height out of your head as anything except names. Everybody with me? Because as you can see, if I tell you it's a rectangle on a piece of paper, you want to call it length and width. If I tell you it's a drawing of a building, you want to call it width and maybe height. Right? Everybody cool? Good. That's the first problem. We're taking care of that. Now, next thing that's important. What's the area of that rectangle? Why? Because it's 2 times 4 or 4 times 2, whatever you want to call it, yeah? Okay, the next thing Mrs. Bad Crumble did probably was this. What's the area of that? 4. Automatically, you know it's 4, don't you? Why? Because it's half of 8, yes? Everyone agrees, right? What shape was drawn there? Rectangle. What shape is drawn there now? Triangle, right? If something happens once in math, how often does it happen? Always. So if a triangle is half a rectangle, that must mean that the area of a triangle is a rectangle divided by 2, correct? Except Mrs. Bad Crumble didn't tell you that was the formula for a rectangle, or for a triangle, did she? What did she say the formula for a triangle was? If you don't remember, you could look at it on your sheet. It's on the data book. What were you told was the formula for the area of a triangle? Right. You were told that a triangle is base times height divided by 2. Or 1/2 base times height, right? Everyone agrees, yeah? And if I draw the triangle this way, everything's cool, right? You can quite plainly see that this 4 is the base. Why do you call it the base? Because it's on the bottom. Everybody agree? Yeah? Okay. Now, if I tell you this is 90 degrees, can you do some math? I'm going to change this slightly. I'm going to make that 3. Could you tell me the length of the diagonal side? What is it? Yeah, you do Pythagoras, right? I will not call it a squared, b squared, c squared because I hate a squared, b squared, c squared. Because as soon as I change the letters, you guys can't do the math anymore, which really, really bothers me. So I will call it Pythagoras because that's what it is. And I will curse to my grave the person who changed Pythagoras to a squared, b squared, c squared. Because if you change those letters and I make the hypotenuse b, all of you will do it wrong. And you will tell me the hypotenuse is shorter than one of these two sides. So I will not say that. But I will say Pythagoras. We all know it's 5, correct? Yeah? Everyone agree? Now, if I ask you the area of this triangle, you're all going to say base times height. What is it? I've redrawn it differently. So what's the area of this triangle? 6. Why, Hayden? 3 times 4 is 12, divided by 2 is 6. Easy peasy lemon squeezy, yeah? Okay. What happens if I take the triangle and I draw it this way now? What's the area of that triangle? It's still 6. Why? Because it's the exact same triangle, isn't it? It's just flipped. Okay. In the black triangle, where's the base? It's the 4. In the red triangle, where's the base? Okay, so the base is 5 in the red triangle. So if I want the area of the red triangle, it's 5 times something divided by 2, yes? Where's the height? Why is the base 4 still? Because I got a 90 degree here, right? And I can turn it. So, is the base the bottom? No. So what's a better definition for the word base than it's on the bottom? Because it's plainly not on the bottom in the red triangle, is it? So give me another way to describe the base.
The
Anusha.
side that touches the 90-degree.
The side that touches the 90-degree angle? Okay. Now, there's no 90-degree angle. Where's the base? Can anybody give me another word, another way to define the base if I refuse to allow you to call it the bottom? Because it doesn't have to be the bottom, does it? So give me another way to describe the base. Or tell me what the problem with it is. Javon.
Do you know what I'm talking about?
If I did, I wouldn't have gone, This is problematic, isn't it? Right? I'm asking you to do something that is difficult, yes? How do you define the base when your entire math career you have been told the base is the bottom? Jacob.
Right, so like if you imagine it as a square, the outside would be where the base is.
Nice. If you imagine it as a square. So if you turn the drawing around and orient it in such a way that you are comfortable, you could then find the base. Are you happy with that? Does that paraphrase what you said? Basically, I believe what Jacob said was, if he imagined this as a square, so if he imagines this is 90 degrees and turns it around, he could make that the base or that the base, correct?
And if you drew a second
Yeah, okay, so you drew a second triangle. There you go.
then it's not the inside.
Yeah, okay. Everybody cool with that? So base, the next thing I want you to get out of your head is the fact that base is, again, just a name of the side to differentiate it from the length or the width. Is everybody cool with that? Yeah? Okay. Wow, this is going well. Okay, so now I'm going to ask you this. What would the area of that triangle be? Right. X squared divided by 2. We remember grade 9. X times x is x squared. And since triangle, I got to divide it by 2. Agreed? Everybody good? Okay. Now can you tell me the area of that triangle? You all know the formula for the triangle. What's the formula? Base times height divided by 2, yes? Okay. $30 brains. It's a simple formula, isn't it? Does the formula get any simpler? The only simpler formula is length times width, isn't it? So that's the easiest formula I can give you. You all know what a base is. You all know what a height is. So this shouldn't be difficult, should it? No. Okay, so go. Both x's are. If I do this, it's pretty easy, isn't it? What do those lines mean? That they're all the same. That makes it pretty easy. But I didn't. My eraser's not working. Pretend I erased all those lines. Why do you laugh at me so much, Mike? It hurts my feelings. I'm just, Aiden, or Micah, I'm just kidding. It doesn't hurt my feelings. I'm okay. What are you going to do? Talk amongst yourselves. Figure it out. There's 30 brains in here. 30 of you should be able to tell me the area of this triangle, considering how easy the formula is. I'm going to push pause and let you think about it. Anybody figured this out yet?
No.
Why? What's the problem?
Can I guess?
Yes, please do. That was the whole point.
One side is 7 and one side is 8.
One side is 7 and one side is 8. No, because they're both x. They're the same number. Excellent. You do know the base. The base is 9. It's on the bottom. So what can I do? What is the problem here? Why can't you tell me this area? Josh? You have no height. Or do you? Where would you tell me? Sorry, Josh, I interrupted you. Absolutely. We don't measure our height up the side of our body, do we? Where do we measure our height? Top to bottom. So I better change colors. Isn't that the height? Okay. What did that make right here? A 90-degree angle. What did that line do to this triangle? Split it in half, because those are the same. So what did that line do to this? Make it what? To make it 4.5, yes? Now, can you do some math with that? What math can you do with that red triangle that I have now outlined? You can do Pythagoras, can't you? This side right here would be the square root of x squared minus 4.5 squared, wouldn't it? Wouldn't it? Right? Hypotenuse minus the leg. It's all squared and I square root it, right? Now, does that give me a height? Does it? If I choose 9 as the base, where does height go from a base? Where does my height go from my base? Straight up. So, if you choose this as the number you know, the base, doesn't that make that the height? And isn't that right here? So could you tell me the area? What's the base? No, it's the whole black part now. What's the base? 9. What's the height? The square root of x squared minus 4.5 squared. Then what? Divided by 2. Was there anything new here? Was there? Have you seen Pythagoras? Have you seen base times height? Have you seen triangles? Was there anything new? Then why did 30 of you, and I'm not angry, I'm just wondering, what about this question made 30 of you not able to tell me the answer? There's not enough to solve it, but there's enough to give me an answer, isn't there? So what made it weird? If you knew all the steps, what made it difficult? The process. You had not seen this before, put together this way, did you? But did you all have the tools to do it? Everybody agrees? Good. Oh, wow, this is going better than I thought it would. Okay, so now we have made some very important changes to our prior knowledge, yes? Base is not the bottom. Base is where we start from, yes? Who chooses where we start from? If I drew this triangle this way, without a 90 degree, who chooses where we start from? If you slice that down the middle, there's your H, there's your B. Because they got to be opposed to each other, correct? Perpendicular to each other. If I have a 90, 3, 4, do I need to find a height here? No, of course not. Why? Because I have a base and height if I do what Jacob said, which was turn it. Reorient it so I can work with it, right? If I told you that I was building a building with this roof this way, and I told you I wanted you to paint it, even though the building looks like this, you're looking at the roof, when you're doing the work, do you have to deal with it that way? Or can you turn it to be this when you're working with it? Is that allowed? Yes. Do not get trapped by the drawings. Is everybody with me there? Yes? Okay. Good, 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 good. Everything is coming up rosy. Now, I'm going to give your brains a break from what we're doing currently, and I'm going to give you a 5 gummy bear puzzle. Not new stuff, it's a puzzle. The first 5 people to solve it get 5 gummy bears. You can work together, but if you work in a group, the whole group is split in the gummy bears. Ready? Everybody's ready? Go. That little red circle means nothing. It's funny, as soon as I put a prize on the table, nobody wants to help each other. Oh, it's a tongue tattoo. Nice. And I'm doing this because it's a Friday afternoon. If you don't want to play, you don't have to, of course. You could just talk to your friends. It's essentially a break that I'm offering your brains from math. Holy crap, go get your 5 gummy bears. That was fast. Holy crap, go get your 5 gummy bears. That was fast. 3 more people are available. Oh, here comes Lassa. No, he's going to the bathroom.
No, I don't know what bathroom is.
Oh, so then why are you here?
Yeah, why? Because I asked you. What it
Oh, what the word pattern means.
Yeah.
Okay. There's something is happening in this whole pyramid that will allow you to put in the empty numbers.
Oh, yeah. Can I tell you then like this?
Yeah. Don't say it out loud. Write it down. Start across there. Start at the bottom left and just write the 1, 2, 3, 4, 5, 6 numbers.
Here?
Start here. Yep. Just write the first number. Write that one. Okay. Keep going.
This one.
Yeah, then this one. Peeky peekies. Okay, then this one. Then this one. Yeah, okay, go get your gummy bear. 2 people are left. I'll be doing these on many Fridays, ladies and gentlemen. I recommend starting to work together because some gummy bears are better than no gummy bears. Sure. Hard to do, though, isn't it, Leasley, without telling them? Yeah. Oh, Karen. You go get a gummy bear, sister. There are 5 more gummy bears available. No, I said 5. Try to take lots of reds and greens because I don't like them very much. Sorry, Jacob. Let's see. Marcus.
Yeah, so it's just cousin sister, right? And like it was in the fall. And it was like Prius eyes kind of it's fine.
Josh. Oh, I'm in
Guess
a good
what's the
spot.
worst?
Together.
On there. I get cold.
Oh, now I gotta walk way over to Indigo, are you getting the last 5 gummy bears?
She actually kept it for me.
Maybe. I don't know either.
Like obviously
Why?
we
Be
made it
strong.
like I read this like that.
You damn right you're getting the last 5 gummy bears. Are you sharing them with Mercy? Did you work together? Hurtful.
He has 6. Wait, which one's the Imprega?
What? Red and green. Why would you be that way, Derek? Hurtful.
Like he's like steady.
I'm not like
He always
that.
do better than us.
What's the
Like,
pattern?
in an exam, he did so much better.
What's the
Even though,
pattern?
like, we studied so much, we made, like, so much.
Oh, I'm getting
He
dizzy.
did nothing. He used to get stuff. But he still.
Yes, I know that.
He's so like, I don't know.
What's the pattern? And more importantly, if you were one of the 5 people that solved it, how did you know the pattern? Nobody wants to share? You figured it out in the long run? So what's the pattern? Where was the hint that allowed you to spot it? Lassa.
We did it in the second class, so I know.
What?
We did it in the second class, in
What?
our math class at the elementary school.
Okay. So what's the pattern?
What is it?
Okay. Josh, what's the pattern? You put your hand up, didn't you?
Yeah, well, I saw like 41 plus 50 is 91, and then 16 plus 25 is
Okay, so you took a guess. You did some subtraction here. You did a little math. You said that was 41, and then you happen to notice 16 and 25 equaled 41, right? And then you thought, oh, if it happens once in math, how often does it happen? So he tried. He said, okay, well, if 16, 25 is 41, then that would have to make that 25. Okay, 25, 25, 50. Okay, that works. So if that's 25, 11, that had to be 14. 14, 11, 25. Okay, which means, oh, hey, 5 and 9, 14. So that had to be 6. And then you just follow it along. The bottom 2 add up to that one. Oh. Now, was there any math skill involved? No. Right? But seeing numbers and seeing patterns is a pretty useful skill to have in math class, isn't it? Nice. I'm so happy. Oh, all that recorded. What a waste of space. Now YouTube's going to have a couple more megabytes just wasted. I feel bad for YouTube. They only have a bazillion terabytes. So, all right. So we're good with triangles. We're good with squares and rectangles. We're good with background. I think we can go ahead and turn to page 27. All right. Before we get into what we are talking about this unit, or for the rest of this unit, I remind you of the fact that, once again, while the math that we are about to do is not complicated, it really isn't. You just saw it. It's length times width, base times height. It's easy math, yes? The understanding of how to apply it in this unit causes trouble. Everybody cool? All right. So before I go too much further, I need to be aware of what I'm dealing with in your people's understanding of the vocabulary that is used in this unit. That very first line, area is in 2 dimensions. What is a dimension? A side? Okay. Come on, there's 30 of you. Somebody else has an idea of what a dimension is. You all know what 3D means. What is a dimension? I have one word for it, side. Give me another. Josh. Shape? Okay. Give me another. I'm not saying those two are wrong. I want some brainstorm action here. Pardon me? Image? Okay. A good teacher would have been writing this all down, but I'm too lazy. Side, image. Damn it, I already forgot Josh's. Shape, size, shape, image. Okay, more. I'll change the question slightly. How many dimensions do you see in? 3. Okay, what are they? Length. You can all tell how long something is, can't you? Right? You can see that my arms go from here to here. Okay. What else? Width. Okay. You can all see that my hand goes from pinky up to thumbkin. Right? Well, that's a song my mom used to sing. Where is Thumbkin? Where is Thumbkin? Here I am. Here I am. How are you today, sir? Very fine, I thank you. Run away. Run away. Your mom didn't sing that to you? No. And it was all 5 fingers. Where is Pointer? Where is Pointer? Here I am. Here I am. How are you today, sir? Very fine, I thank you. Run away. Run away. And then where is Middleman? Which, when you're like 6 months old, isn't a bad one, right? But, where is Middleman? Where is Middleman, right? Here I am. Here I am. How are you today, sir? Screw you. No, seriously. Very fine. I didn't run away. Where is Ringer? Where? And that's a hard one, right? It's hard to make your ring finger stick up, right? Because your ring finger is missing a tendon. It's one tendon short from all your other ones. That's why you can do this with your ring finger. Floppy, floppy, McFlopperton. If you bend your ring finger, it's the floppiest of them all. Anyway, where is Ringer? And then where is Pinky? Where is Pinky? Here, you guys don't know that song? Maddie, you said you know that song? Nice. So you can go home and say, Mr. Marge's mom sang the same song to him. But I bet it was your grandma that sang it to your mom. Possibly. All right, so where was I saying? Oh, right. You all know that Thumbkin goes down to Pinky. So you can see in width, yes? What else can you see in? Depth, right? Because if I turn sideways, can you still see me? Yes, because I don't disappear, right? So I'll ask again. What is 2 dimensions? What? What did you say? Flat. Yes, absolutely. 2 dimensions is dead flat, right? Is this paper 1, 2, or 3 dimensions?
3.
You're just saying numbers. 75! It goes through time like the Starship Enterprise. Seriously, how many dimensions does paper have? 3. Of course it has 3, right? Because it's got a length, a width, and it has a depth, doesn't it?
Yeah.
It's hard to measure, but it's there, isn't it? How do you know it has a depth? Well, no, it's because it's curvy. If I was able to hold it perfectly flat, how would you know it has a depth? It's an object. It's in space. It has to have a depth. If I stack 1,000 of them up, do I get a stack? So if there was no depth, could I get a stack? No, because 1,000 plus 1,000 0 times is still 0, right? Okay, so we're all aware that this has 3 dimensions. What if I put it on the table, just like it says here, a sheet of paper covers a certain area of the desk below. Right now, my whole desk is brown, yes? Except for this, my desk is brown if I, had a tidy desk. But we all know I don't because I'm a slob. This paper is covering part of the desk, yes? The part that it's covering, does it have a depth? The part of my desk covered by the paper, does it have a depth? No, it only has a length and a width. Is everybody cool? Yeah. All right. And we just spent like 20 minutes talking about two-dimensional shapes, yes? That you know backwards and forwards, but I messed you up slightly by turning them, yes? But we're all cool now, right? Okay. What do I need to do to something that is flat to give it a third dimension? I could bend it, right? Okay. So I could bend it, and now I pretend that's perfectly full. I have now 3 dimensions, quite visibly 3 dimensions, yes? I have a length, a width, and a depth, right? Everyone agrees? Yeah? Okay. So I started with 2 dimensions, and I can do a whole bunch of origami, and all of a sudden I have 3 dimensions, yes? So if I understand how to work with this, do I understand how to work with this? Hey, you try to fold something 3-dimensional out of this. Do I understand how to work with this if I can work with this? Yes. Do you all already know how to work with this? So you all already know how to work with 3 dimensions. Everybody cool? Everyone's going to be confident, right? Nobody's going to give me any crap at I've never seen it before. Are you? Because you have all seen 2-dimensional shapes, yes? Okay. We are going to work today and today only with 2 3-dimensional shapes. We are going to work with my good friend, the prism. How many of you know what a prism looks like if I showed it to you? A great many of you. Most of you are putting up your hand, yes? So, if I were to go over here and I were to draw... How many dimensions does this thing that I drew actually have? 2, because I drew it flat. How many dimensions is it representing? 3. Excellent. Okay. Do you all agree that that is a prism? Or not?
No.
That's not a prism? Oh, okay. All right. Is it a drawing of a prism? Okay, what makes it a prism? Because it is indeed a prism. What makes that a prism? Josh. Okay, I agree. Fine, no problem. So what if I drew this? Still a prism. But Josh just said this is a prism because it's a rectangle. This is not a rectangle. So let's refine our definition. Talk to your neighbor. Explain to me what a prism is. See if you can figure something out. Take 30 seconds, take a minute. See if you can come up with some ways that we are going to be able to write a definition here. We're not going to draw it because over here there's a spot to draw it. I want you to figure out the words for a prism. See if you can. What makes something a prism?
Can you show the drawings?
Sure. You laughing at me? You laughing at me? I don't see anybody else here. You seen that movie ever? Never mind then. Carry on. Do your math. Micah, I want to move you further back in the room. You're too intimidating that close to me. You're an intimidating fellow. You're a giant. When was the last time you grew? Have you stopped growing? Wow. That's not fair, man. How come you're using up all the height?
Don't blame me.
How tall is your dad?
None of us wanted to do it.
His parents aren't that tall.
Shut up your face.
They are.
How tall are your dad's and mom's brothers and sisters? How tall is your grandpa? How tall is your grandma? How tall is your other grandpa? How tall is your other grandma? That ain't fair then.
It's coming from my dad's side.
Okay. All right, that's enough time. Who would like to share some part of their definition? Who has something for me? Karen, hit me. What you got?
A solid geometric figure whose two end faces are similar, equal, and parallel.
Somebody went to Google. Wow. Okay, good advice to everyone. Is Google a good source of information? Yes, it absolutely is. It is a matter of fact, it is the card catalog of every piece of knowledge that humans have ever had. 2, read that whole definition again.
A solid geometric figure whose two end faces are similar, equal, and parallel. Rectilinear figures and whose sides are parallelograms.
Excellent. Now, somebody explain that to me, because ain't one of you understood that. Is there? Do any of you understand that definition? What's rectilinear? Rectum damn near killed him. Get it? You haven't heard that joke, Derek? Little kid comes into kindergarten class, says, I'll tell the whole joke. Kid comes into kindergarten. Teacher says, Jason, why are you late? Oh, teacher, you should have seen it. I was crossing the street. This car hit this kid. Hit him right in the ass. And the teacher says, rectum, Jimmy, rectum. Rectum damn near killed him. Now, back to rectilinear. What's it mean? Because, Karen, that is the perfect definition of a prism. Does it help any of you? Why? Because you don't know what rectilinear means. You don't know what parallelogram means. You don't know all those words, yes? So, while Karen is perfectly right, let's refine it so it's something that we can use. So, we know some of those words. So, should I put it on the board? Yeah. Okay, let's see if we can get it on the board.
Put it on board.
Damn near killed him. Did you Google definition of a prism? You're not in trouble.
No, I just searched prism.
You just prism in the Google search bar.
Yeah.
You just pushed prism.
Yeah.
Okay? Come on, Google.
Oh, Google load.
Prism. So which one? Okay, no problem. By the way, it is not the Canadian band. There we go. Okay. Solid geometric figure. Are we okay with that? No problem with that, right? Geometric figure is a $5 way of saying shape, yeah? Okay, no problem. Whose two end faces. End faces. Let's slide this definition over here. Let's slide our drawing over here. Okay. Whose two end faces are similar. Okay. Where would you define, who stole my magic pen? Where would you tell me the end faces of this thing is? Josh. You're going to call this an end face?
Yeah.
Okay, no problem. I'm just going to get some highlighter action here. Everybody's happy calling that an end face?
Yeah.
Why?
Because the other side's the same.
Because the other side's the same. I'm going to have another one over here. Is everybody cool with that?
Yeah.
Okay, so the end faces are similar, equal, and parallel. Well, we know what similar means, yeah? Okay, we know what equal means, yeah? And we know what parallel means, yeah? Means they're never going to touch, right? That's what parallel means. If you're skiing parallel, your skis don't cross. Yeah? Okay, so we know what parallel means. Rectilinear figures. Rectilinear. What do you see in there? that it damn near killed us? Rectangle, okay. What are some properties of a rectangle? Micah?
Two equal sides for
Yeah. 2 and 2. Okay.
2 and 2.
Okay, that's your one turn. What's another property of a rectangle? Or were you going to say the side thing, Josh?
Oh, no,
I was asking, because rectilinear sounds like rectangle, right? So I was asking, how can we use what we know to fix this definition up? Okay. So, all right, good. Actually, that helps. What do you got, Gagan? Closed shape. Okay. What else do we know about rectangle? Yo.
It's like a long square.
It's a long square. Okay. What are the angles? 90s. All right. So we know lots of stuff about rectangles, yes? So if two things are parallel and rectilinear, that must mean they are in a line with rectangles, yes? Okay. And the sides are parallelograms. Where would you put the sides on this triangular prism? The other parts, right? This here, the bottom and the back, yeah? Okay. So, this is saying that basically we start with a shape, right? And that shape repeats over here, yes? And what separates those two shapes? A line? You would call this green area a line?
A rectangle.
A rectangle.
Yeah.
Now, is that an easier definition to work with? A shape repeated with rectangles between them. Is everybody cool with that? All right. So let's tidy that up. What is our definition of a pyramid or a prism? Is it any kind of shape or is it a specific shape? Any kind of shape. How many dimensions does it have to have?
3 to 4.
A 4-dimension?
3 dimensions.
3 dimensions. Okay, so it's a 3D. Now, we can use the word shape, yeah? There's fancier words, isn't there, though, right? But do those fancy words really help us out? No. I would say polygon. Do I need that word? No. It's a 3D shape, because that's what we're going to use in real words, right? Made up of what? We had to start with a 2-dimensional shape, didn't we? Because this was a triangle, yeah? If I started this one from there, it repeats to the back, doesn't it? And we still have rectangles between them, yes? So, a 3D shape made up of a repeated what? A repeated 2D shape, yes? Separated by what? Separated by rectangles. Is everybody happy with our definition? Can everybody understand it? Okay, so let me ask you. Can I have a rectangle prism? Can I start with a rectangle and slide it backwards? Yes. Can I have a square prism? What would we call a square prism? A cube. Nice. Can I have a triangle prism? Can any of you think of a real life example of a triangular prism? No, a pyramid is not a prism. A pyramid is a pyramid. Josh? Roof of a house is a perfect one, yes? Right? If this was a roof, here's my house. The roof is a triangular prism, yes? Yeah. Awesome. How many people have had a Toblerone bar? How many people have shared a Toblerone bar? Put your hands down. You don't share a Toblerone bar. They're the greatest thing in the world. You do not share a Toblerone bar. You show it off. Look what I have. Kai, have some? No. Of course you don't. You don't share a Toblerone bar.
My kid doesn't share a large pizza. It's true.
I get it.
I'm speechless. You don't like Toblerone bars?
For Christmas, I got like this huge one I just gave to my friends. They don't like them.
What is there not to like about a Toblerone bar? I can't even talk.
How?
What is there not to like? Is it the hazelnuts?
I like hazelnuts. I just don't like them.
Interesting. Is there anybody in Marcos's camp that does not like a Toblerone bar?
I think they're like decent, but they're not like a wow factor.
Really?
Yeah.
Huh. You people have led good lives. Tiana? Why not? Oh, you can't eat nuts? Any kind of nut?
Okay.
Damn.
That makes sense.
Pardon me? You can't have eggs either? Damn. I feel your pain though, sister. I can't have gluten. But it won't kill me. Do you carry an EpiPen, Deanna, just out of curiosity? You do? Cool. Not, you know what I mean, right? You know what I mean. Okay. I'm ready. I want to be a hero. My whole life, I've been waiting to be a hero. And it hasn't happened yet. A couple of summers ago, some guy got stuck in a wheelchair on the railroad tracks in Chilliwack. Literally 2 minutes before I arrived at that intersection. I arrived at the intersection. There's cops and everything around. What happened? This guy in a wheelchair got stuck. And some guy got out of his car and saved him. And I got there 2 minutes too late, Anusha. I mean, I'm happy the guy was okay. But I wanted to be the hero. I would have gotten out and saved him. I keep waiting for the chance, and it's just not happening. Okay, so we can have a triangular prism. Can I have an octagonal prism?
Yes.
Could I?
Yes.
Could I draw a stop sign? And I know it's green, so be quiet. Could I repeat it back here
So you mean go instead.
again? So I can have an octagonal prism. Can I have a circular prism?
No. No, you can't.
Would not be because it's
You're awesome. Can I have a circular prism, Jovan? Yes. I look at you. Maybe. I think. I'm not actually sure. I don't know. Can I?
You can't.
I'll say yes.
Stick to it. Who agrees with my man Jovan? Can you have a circular prism?
But I don't think you can have a circular prism because the middle of it's supposed to be a rectangle, but circles are just like smooth.
What shape's that?
Dude.
What shape is that?
Rectangle.
That's a rectangle.
It's a rectangle, right? Everybody agree? What shape's that?
That's a rectangle. That's a circle.
That's a circle. Is this a circle?
Yeah.
Now, nobody be wise. Squished. Is it a circle?
Yes.
Is that a circle?
Yes.
Did this circle repeat to here?
Yes.
Were those two circles separated by a rectangle?
No. Yes.
So can you have a circular prism?
Yes. No.
Of course it's just a cylinder. But it's technically a circular prism, is it not? Yes. So let's draw a few of these. There's a rectangle one. Easy peasy lemon squeezy. There's a triangle one. It just repeats to the back. There's a circular one. Everybody cool? Yeah? Oh, it's 2:09. We're going to get through pyramids, then we're going to stop. Yeah?
You're not gonna have homework because
No, you're not. It's the weekend.
thank you.
Yeah.
Come on.
Thank you. Thank you.
The other one we're going to look at are pyramids. Everybody seen a pyramid, yes?
Yes.
Everybody has. Is a pyramid a prism?
No.
Do you say that because you know a pyramid isn't a prism? Or do you say that because Mr. Myers has done two categories, so obviously it's not?
Two categories. That's obviously not.
And when Anusha said, yeah, sure, you can have a triangular prism, she said pyramid. And I said, no, pyramid's a pyramid.
Yeah.
So everyone who was paying attention is like, no. Now, this is where I tell if anybody isn't paying attention, because even though I've done all this, I will still say, is a pyramid a prism? And one guy will usually go, yeah, because they've been listening to music or something for the last hour. Is this true? Did I get anybody? No? All right. So, tell me what a pyramid is. Talk to your neighbors. And triangles? Has to be triangles? Okay. So let's talk. Oh, what? Has to go up and make a point. Okay. Keep talking. What else you got? Micah, what you got?
Have to have triangles around each side.
Triangles around each side? All right. What else you got? Has a base. Oh, yeah. Does a pyramid start from a base?
Yes.
Does that shape repeat? Does it repeat exactly, or does it repeat similarly? Ooh. That's a badass question. It's similar, isn't it? Right? If I start with a square on the bottom, Derek says it's got to come to a point, yes? So at every point up this pyramid, is that square repeating? It is, isn't it? But is it the same square? No, because eventually, what happens at the top of that pyramid?
It makes a point.
It's a point, and then what's left of the original base? Nothing. It shrinks to nothing. Yes? So it's, oh, damn. Oh, wait. We're moving a pyramid, so we're rolling it on logs.
Oh my goodness.
Yeah, because now we're going to get some social studies into math class.
Oh, please.
Oh, but we left the bottom of our pyramid.
Slaves,
Please, no.
You know, you're right. They were indeed slaves.
What did you do?
There we go. So, that. Excellent. So what is the same in these two definitions?
Oh, man, what the heck? What is going on?
Is a pyramid a 3D shape? Excellent. Is it made up of a repeated 2D shape? Okay. A 3D shape made up of a repeated 2D shape. But what happens now? Now the definition has to change, doesn't it? What happens to that repeated 2D shape? Yes. A repeated 2D shape continually shrinking to what? I forgot the shrinking. To nothing, right? Everyone agree? So, what would you call this pyramid? We start from a 2D shape. What would you say is the start of this pyramid? The base? And what would you call it? Here's the base. There's where I'm starting. What would you call that? You could call it a square if you knew the sides were the same length. So what would be a better word for it? Rectangle. Because even a square is a rectangle, yes? So a rectangular pyramid. Everyone agree? Could I start from a triangle? Sure I could. It would look like that, right? Everybody agrees? Could I start from an octagon? Sure I could. It would look like this. Whoop, 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 whoop. Right? Can I have a circular pyramid? What is it? A cone. Whoop. Dot, 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 dot. Dunce cap. I was so appalled to find out what those things were when I was a little kid. Do you guys know what a dunce cap is? I saw it on cartoons, right? Always shows up on Elmer Fudd's head when he's doing something stupid in Bugs Bunny. Little triangle cat, little cone hat that says dunce on it. I had to ask my mom what it was. Do any of you know what a dunce cap is?
No.
Like, you know what it is, but you know what they were used for?
What?
if you did something stupid in class, the teacher would put the hat on your head and make you go stand in a corner with a hat on your head that says you're stupid. Can you believe that?
Yeah.
You can believe, well, I know. I mean, back in the day, people beat kids up too. But there's some, and yet, is that a tradition you think we should keep?
No!
No, because some traditions are stupid, aren't they, Anusha? And yet, other traditions, people are like, how dare we change that? How dare we change that tradition? Tradition's so important in all thy son's command. Rune's going to ruin the country to change the lyrics of the anthem. Mm-hmm. In all of us command. It makes no difference. It's just a song, man. Makes no difference whatsoever. I do. Because it makes more sense.
Yeah, I guess it doesn't.
In the original anthem, apparently, Gagan, and Anusha don't have to give a rat's ass about anything because they're not sons of anybody. So they can do whatever they want in Canada. The rest of us guys, we got to, stand on guard for thee, but all the girls... Because it's only in your sons that you command. I think it a little unfair to all the women who go out and fight in Afghanistan and things that we don't get to tell them that we're guarding them too. Don't you? And yet, people are up in arms about it. But if you were to say to one of those same people whose argument is always just this, it's tradition. Okay, next time your kid does something stupid at school, the teacher should be able to beat him with a belt, right?
What? No!
It's tradition.
No!
I know, no, Micah, you're just proving my argument. Thank you, though. I need that help. All right, so we all good? It's 2:19. We're stopping there. You have a good weekend. You have no homework. No, there's yours to study from. Now, if you're at all interested, I want to show you this funny gag.
Oh, man, there's another experience.
Yeah, not